this time the digital twins get their showtime. We will talk about the digital twin-based engineering of SINAMICS drives for maximum efficiency which can be reached. And we will be sharing this information from Automha, who is a global leader in automatic warehouses who aimed to improve drive system efficiency of their storage and recovery machines. They're coming from multiple places on the globe. Please welcome Automha Mechatronics Engineer R&D Department Enrico Comotti and Siemens Business Development Manager for Drive Simulation Anton Bukov. Hello.
Hello.
Hello. Hello, everyone. Very crowded today. We are really happy and excited to be here to introduce you something truly revolutionary story in drive technology. Today, we will talk about next level engineering, about completely new approach to technology that changes the game and takes your automation project to new heights. Digital twin and their vital role in shaping the future of drive systems. This is not just another simulation. Our solution is a groundbreaking tool. It allows us to combine digital world and real world of drivetrain components, enabling to simulate machine behavior in advance. Imagine this. Through simulation, you can explore different modes and scenarios, ensuring our solutions are not only efficient, but also robust under different circumstances. It's like having a crystal ball that shows how our machine will perform in a real field. Let's dive into this exciting world together, where simulation opens new possibilities for us. Enrique and I will share the story of our recent project where we applied this approach and achieved a great result.
So, dear to everyone, I'm Enrico Comotti, and I'm working in the research and development team of Automha, which is a company that is a leader in the automatic warehouse sector. The company counts on roughly 230 employees, and it delivers automatic warehouse all over the world. For our automation solution, historically, we rely heavily on a Siemens solution. For our simulation and digital twin, we are used to the Siemens ecosystem with solutions such as plant simulation and mechatronic concept design. Then today, we will focus on a specific solution of the Automha portfolio of moving machine, the rush mover system. The rush mover system consists in a fleet of rail-guided vehicles that travel along a fully modular rail loop in order to transfer pallet, any kind of pallet. Inside a factory, this system fulfills the task of interconnecting the production line with the warehouse, with the shipping area, for the seamless transfer of loading unit inside the factory. Each of these machines, each of these rush mover has a travel powertrain. This travel powertrain is composed by a Siemens brushless and a SINAMICS servo drive system, which is controlled by a SIMATIC PLC. In this year, within one of the projects of our R&D department, we focus on the renewal of the mechanical design of this machine. In the old generation, the machine was equipped with a differential gear in order to smoothly take curves. With the new generation, for the sake of simplicity, we avoid to use a differential gear. What we use to transfer the traction is to use an horizontal traction wheel that is directly pressed to the central rail of the loop. In this way, we transfer the traction. So, what was the challenge? The main challenge of this project was to try to shorten the development time of this project. Why? Because normally when we approach a new research and development project, we go the first phase is to finalize the mechanical and the electrical design of the machine. Once this phase is closed, we are ready to send to our purchasing office the full bill of material. And then for us, for the research and development team, start the waiting time. Means that there is a procurement time of this product that we order in the bill of material that can take very long. Could take 1 month, 2 months. And in this 1, 2 months, research and development have no control. Added to this lead time, we have also the lead time that is connected to the assembly of the first prototype. So, as you can see, in general and overall, every time we start a new prototype, there is always a window of time of 3-4 months where research and development cannot work directly on the prototype. We were looking for a solution to shorten this time and to put our hand directly immediately on the project. And Siemens provides us a digital twin as a solution.
Yeah, and now DriveSim Engineer comes into play and brings the art of drive simulation to life. This is a complete digital twin of Next Generation SINAMICS drives, designed to achieve realistic results through virtual commissioning. I would like to emphasize a few outstanding features that contribute to achieving success. First of all, DriveSim Engineer has firmware in the loop simulation with absolutely the same parameters and configuration as a real SINAMICS. Fully integrated in TIA portal and start drive, making your virtual commissioning process as intuitive as setting up a real drive. Enhanced safety. Virtual engineering and commissioning reduce the needs for on-site visits, improving safety. And our new key exciting feature, connection to Simatic S7 PLC Sim Advanced. With this function, you can simulate entire machine, including PLC, and unlocking new possibilities for testing and optimization. DriveSim Engineer covers all your needs along the way. With this powerful solution, you can demonstrate all functions in advance, get knowledge, experience through virtual training during the design phase, and optimize your current project. Sure, you can do virtual commissioning your machine even before the hardware is delivered to the factory. And now, Enrique will show you details about our implementation process.
So now we come to the point where we share how we made the sausage, So how we make the simulation. So we start from the mechanical design of the machine. We took this mechanical design, the 3D design, and we created a physical virtual model of the rush mover. We took this virtual model of the rush mover and we set it into a virtual rail loop. This was how we prepare the physical setting in the virtual environment. Then we couple this physical model to our automation via PLC Sim Advanced and DriveSim Engineering. Once the physical environment was coupled with our automation environment, then we were ready to run our simulation and our analysis based on the trace that we could gather from the simulation. And which trace, which curve we were interested to. We were interested in velocity curve, acceleration, current curves, and we tested with different settings and with different payload. And this was what we did. During this experience with the simulation, we were able to appreciate the different benefits of working with DriveSim Engineering. First of all, we were able to assess the cinematic of the machine in a virtual and simple environment. Secondly, and it's connected to the first, we were able to narrow down the best combination of speed, acceleration, and payload that we could also find in a real scenario once the machine is settled inside the plant. Another positive point was that we were able to test the safety function of the machine. Another thing that we really like it is that we were able to do some early knowledge transfer from the research and development and our colleague from automation and service, so that they could have the chance to have hand-on on the prototype even before the prototype was ready here in-house. And this is good for us because it lowers the resistance that we normally, as a research and development, encounter when we introduce a new machine inside the company. This was good. So on overall, we can say that we really managed to shorten our development time by because of different reasons. First of all, we were able to parallelize different R&D processes. The other thing is that we have tested a lot of scenarios inside this virtual environment, and when it came the time to test the real prototype, already a lot of scenario was tested, and we could just focus on the relevant one, on the real machine. The other thing is that we also reduced the time that we spent doing some trial and error testing, like seeing the machine in physical running and try to find out what was wrong. And this is like help us to optimize our process. And the other thing for the future, we also think that the time invested in creating this digital twin, it will pay off in the future when colleagues from us in the field will have some special problem of the machine. They will call us, and we could recreate the problem of our colleague in the field in a virtual environment and provide them better support. So to sum up, the DriveSim Engineering increased the efficiency in the prototyping and testing phase. We accelerate our project of improving the rush mover system, and in general, we assessed that we probably save something like 30% of our development time. That is, and now I leave to Anton for closing.
Thank you for your time and attention. We would like to invite you to our DDT booth, where we'll talk to you personally and answer your question. Thank you, and see you soon.
Thank you, Anton and Enrico. Great presentation, great information. Now, I mean, you're purely in. I can tell that with every cell of your body, you live this device. That's for sure, and the solution. But how long have you been working together to develop this solution?
It didn't take long because DriveSim Engineer helped us speed up testing and commissioning of new machine, and we completed this project in 4 months, saving totally 2 months. So yeah, that's it.
Is that the usual speed of projects which you kind of realize, or are there like even faster ones, or some are taking longer, or is that the average?
So faster, but...
Well, from our side, what we value a lot is that when we start a project with a new solution of Siemens, we always get the support. I mean, we talk with Anton, we talk with our colleague in Italy, we talk with the technical research and development. So it helps a lot, and it's also, for us, it's also something good when we feel a bit more secure to undertake something new.
Yes.
When there is somebody that knows it.
Absolutely clear. Thank you so much. Great insights. This is where we will find you, underneath of the Realize area. You will be around for the next hour or so.
Yeah, I guess
half an hour, something like this.
Yeah.
So if you're interested and want to talk to a passionate Italian, that's the chance to do so. Otherwise, Anton, you will be here for longer.
Yeah.
All right, cool. Thank you. Once
Thank
more,
you.
Thank you.
big round of applause to the two gents.